Okay, so this one is one where you've got two different trig functions. And so sine squared plus cosine squared is 1. And I'm going to end up using this Pythagorean identity, so I'm going to write it over here. Alright, so I'm going to use this identity to replace this sine squared. And the reason that I'm going to replace this is because this is one that has a squared function. And if I were to get everything set equal to 0, so if I were to go ahead and move everything over and make this minus cosine minus 2 equals 0, I would need to be able to backwards FOIL this, and I can't with it being sine and cosine in the same problem. So I need to change this sine squared using this identity. And so sine squared is going to equal 1 minus cosine squared. And so I'm going to plug in 1 minus cosine squared right here for sine. And then when I do that, that's going to give me something that will allow me to backwards FOIL after I distribute this 2. So this is going to be 2 minus 2 cosine squared minus cosine minus 2. And so if I combine the 2's, that 2 and that 2 will cancel. And so then I'm left with this negative 2 cosine squared minus cosine. And to solve this, I'm going to go ahead and factor out a negative cosine. And that's going to leave me with 2 cosine plus 1. And so then cosine equals 0, or negative cosine equals 0. That's just like a negative 1 that I can divide off. And so I would still get cosine equals 0. And then this is going to give me cosine equals negative 1/2 when I divide by 2. And so I'm going to paste this little thing up here. Alright, so cosine is 0. Cos x is going to be 0 at pi over 2 and 3 pi over 2 if you look at your unit circle. And then cosine is 1/2, negative 1/2. That's going to be right here and here. This is where the cosine is negative. And so I need angles in the second and third quadrant. And so if I look on the unit circle, that is going to be second and third quadrant where cosine is negative 1/2 is going to be at 2 pi over 3 and 4 pi over 3. So theta here equals 2 pi over 3 and 4 pi over 3. And so these are my 4 solutions. Alright, number 7. This is one that's number 8. This is one that's similar to one that we did a little bit ago, and I want you to try on your own by pausing it. So it's similar to this one where we subtracted the cotangent over and then factored out a GCF. So try this one, and then you can play it back and make sure you got it right. I'm going to go ahead and subtract this cosecant, or this 2 cosecant over, and then that's going to give me something that I can factor a GCF out of. So cosecant, and then that'll leave me with secant minus 2 equals 0. So I'm going to set both of these equal to 0. And then because they're secant and cosecant, it's easier for me to change this to sine and cosine and solve like that. So this is 1 over sine equals 0, and 1 over cosine equals 2. Now when I solve this, this is like a 0 over 1, so when I cross multiply, I'm going to get 1 equals, sine times 0 is just 0, so nothing is going to give me a solution there. Right here when I cross multiply, 1 times 1 is 1, and then 2 times cosine is 2 cos, and so then I'm looking for cosine equals 1/2. And so when I'm looking for my angle, I'm going to look where cosine is positive. That's going to be in the first and the fourth. And so the first and the fourth, where that's going to be 1/2 is at cos x, so that would be at pi over 3 and 5 pi over 3. So right here, theta would be pi over 3 and 5 pi over 3. Alright, last one before we go into a different way of solving. This one is one where you're going to need to turn everything into sines and cosines. There's nothing that we can factor out. So basically what I'm going to do to make this easier is change this tangent into sine over cosine. And so this is like a sine over 1. So here this is going to leave me with sine squared over cosine equals, not 0, but equals 2. Alright, so now I can get a common denominator. And so this is going to be cosine squared plus sine squared over cosine when I get that common denominator. And so then cosine squared plus sine squared is just 1. That's from the Pythagorean identity. So I've got 1 over cosine equals 2. I'm going to put that over 1 and cross multiply. And so this is going to be 2 cosine equals 1. And so then cosine will equal 1/2, and that's what we just got right back here. So cosine is 1/2 at pi over 3 and 5 pi over 3. And so my solutions there would be pi over 3 and 5 pi over 3. Alright. Now, sometimes it may say solve with no domain restriction, which basically just means instead of finding answers between 0 and 2 pi, like we did on those last examples, is when there's no domain restriction, we've got to find every solution. So there are infinitely many solutions, and so we will be finding solutions from negative infinity to positive infinity. And so that means if I know that 0, or let's say if I know that pi over 6 is a solution. If I go 2 pi, or add 2 pi to pi over 6, that would be like going a full way around the circle. And so that angle would also be a solution. And if I add another 2 pi, that angle would be a solution. And so I could keep adding 2 pi to this angle as many times as I want, and I'll still have this same point, which will give me the same solution to the equation that I'm solving. So whenever you are solving equations that have sine, cosecant, or cosine or secant in them, you're going to add 2 pi in, and basically this just means multiples of 2 pi. So if you wanted to add 1 rotation to an angle, you would put 1 in right here. If you wanted to add 2, you'd put 2, 3, you'd put 3, and so on. And n is in the set of integers. So n belongs to the set of integers. Now, for equations with tangent and cotangent, we said in one of our earlier lessons that the period, or how often it takes for tangent to repeat, happens not at 2 pi, but at pi n, where n's in the set of integers. So when I'm asking you to find all possible solutions to these equations, you are going to take your solutions and add 2 pi n to equations with sine, cosecant, cosine, or secant, just like this, where n's in the set of integers. And if you have tangent or cotangent, you're going to add pi n. So I'll show you with some examples. So every possible solution, that means I'm going to go ahead and make this sine equals negative square root of 3 over 2. So that's going to be negative square root of 3 over 2. Sine is going to be negative square root of 3 over 2 when we've got 4 pi over 3 and 5 pi over 3. So I would take 4 pi over 3 and 5 pi over 3. So I solved it the exact same way that I did before, and since I've got sine in my equation, I would add 2 pi n where n belongs to the set of integers. Alright, so this one, I'm going to solve it the same way that I did one earlier. Sine squared, I've got a cosine in this. I need to make this 1 minus cosine squared using the Pythagorean identity. And so I'm going to go ahead and put that in and then distribute the 2. So this is going to be 2 minus 2 cosine squared plus 3 cosine equals 3. Now I need to get this set equal to 0, so I'm going to subtract this 3 over, and it'll give me a negative 1 minus 2 cosine squared plus 3 cosine equals 0. And so when I put this in the correct order, I'll have negative 2 cosine squared plus 3 cosine minus 1 equals 0. Alright, so next I'm going to factor out this negative, so I can factor. So this is going to be 2 cosine squared minus 3 cosine plus 1 equals 0. And so when I backwards FOIL this, this is going to be 2 cosine and cosine. 1 and 1, and both will have to be minus. And so now when I solve these, I'm just going to set 2 cosine equals 1, or 2 cosine minus 1 equals 0. So that's going to be cosine equals 1/2. And this one, cosine equals 1. And so cosine, if you look at your unit circle, cos is going to be, x is going to be 1/2 positive at pi over 3. And in the fourth quadrant angle for that is going to be 5 pi over 3. And so then cosine equals 1. Cos x is going to equal 1 at 0 and 2 pi. And I'm just going to write 2 pi here. And because I'm going to add 2 pi in, multiples of 2 pi, to all of those angles, that'll take care of the 0 and any other angle that I could find. So where n's in the set of integers. And so this would be my final answer. So theta equals all of that when I add the 2 pi in. Alright, last one. So cotangent squared is going to equal 9 divided by 3. I'm going to divide that 3 off, so that's going to be 3. And so when I take the square root, cotangent equals plus or minus the square root of 3. And so this is going to happen if you go to your unit circle. Cotangent is x over y. And so if I try all those points out, it's going to be in all four quadrants because I've got a plus or minus. But x over y is going to give me the square root of 3 at... let's look at our unit circle. Okay, so if I do x over y here, at pi over 6 if you try that out. And so all of my pi over 6 angles are going to work. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And to each of those, I'm going to take and add multiples of pi. So pi n, where n belongs to the set of integers. And so this would be my final answer there. So these last three are really no different than the first three except for what you add on the end.